Assalamu alaikum guys, welcome back. Today we are going to study the dispersion of the data. In last lecture we studied measure of center. Measure of center gives you the centralmost point of the data, which is also called the average, and we studied mean, median and mode for the data, which all three were the measures of center or measure of central tendency. Dispersion gives you the spread of the data. Okay, so why we study dispersion? Because measure of center does not tell the whole story, right? It just gives you the center and it does not tell you the other things present in the data. So 0 when all the values are the same. So dispersion gives you the measure of spread of the data. It is 0 when all the values are the same, because if all values are the same, then there is no spread in the data. So measure of dispersion will automatically be 0. So if you consider these two histograms, you see both have the central value at the same place between 5 and 6, but this data is more spread here. On the left, this one is less spread and this one is more spread. So if we calculate the measure of dispersion, it will be smaller for this data and bigger for this data. Okay, so that is the whole story basically. So what are the measures of dispersion? One is range, interfractile range, population variance and standard deviation, sample variance and standard deviation. So basically these both are the same. One is calculated for population and one is calculated for sample, as was the case for measure of center. It will have just different notation. Formula will be the same. And then the standard score, coefficient of variation. Standard score and coefficient of variation, they come from mean and variance of the data. So basically range, interfractile range and variance and standard deviation, these are basically the important things. So what is the range? Range is the difference between the highest and the lowest value. Very simple. Just look at the highest value of the data and the lowest value of the data. Take the difference between them, it gives you the range. Okay, so value of the highest observation, value of the lowest observation. So if we have this data, then what is the value of the highest observation? 1883, because this data is arranged, the very last value is the highest one, very first value is the smallest one. So if you just take the whole range, that's why we call it the range, right? Because it gives you from the lowest to the highest value of the data. So you can say that the 1020 is the difference between highest and lowest value. This is the range of the total data. Better than that is interfractile range. What is interfractile range? We give a fraction or proportion of the data that lie at or below a fractile. Okay, so fractile originates from the word fraction. So for example, the median is the half fractile. Why? Because if this is the whole data, right, median is right at the center. This is your median. So the half of the data is below it, or the half of the data is above it. Okay, so we can call it half fractile, 0.5 fractile. So that will give you some idea about the fractile y. So if we divide a data into 3, let's say observation 1, 2, 3, right? Let's say this is the whole data, so we divide it into 3. So this will be 1 by 3 fractile, this will be 2 by 3 fractile. Okay, the first one should start from 0, the last one is always 1, 100%. So why 1 by 3 fractile? Because 1/3 of the data is below it. Why this is 2 by 3? Because 2/3 of the data is below it. So these are 1 by 3 and 2 by 3 fractiles. Similarly, there are percentiles. Percentile comes from the percentage, right? Percentage divide the data into 100 parts. If we say that 25% data is below it, it is the 25th percentile. Okay, so if you divide the data into 100 parts, then each part gives you a percentile. Similarly, if I divide something into decimals, let's say 10 portions, then it gives you deciles. Okay, so what is the interfractile range then? Interfractile range is the difference between two values of the fractile. Let's say if you are considering 1 by 3 and 2 by 3 fractiles, then this difference between 1 by 3 and 2 by 3, this difference gives you the interfractile range. But here we are using 1/3 and 2/3 fractiles. So when you calculate interfractile range, you have to tell us which fractile you are using. Okay. So here you see, find the interfractile range between the first and the second thirds. First and the second third. First third is 1 by 3 and second third is 2 by 3. Exactly what I was talking about in the previous slide. So this interfractile range they are asking for. Okay. So now if we divide data into thirds, because they give us third spot, so there are 12 values. If there are 12 values, I divided them into three parts, 4, 4 and 4, right? So this last one gives me 1/3 fractile and this gives me the 2/3 fractile. Okay, so this is 1/3 fractile, this is 2/3 fractile. Now if you take the difference between them, they give you the interfractile range. So this was 1624 and 1041. They were the fractiles. If you take the difference, this gives you the interfractile range. Other fractiles are percentiles. Percentiles are written as P and deciles written as D. Decile divide the things into 10 data. Okay. So, and similarly quartiles are something which divide into 4 equal parts. Okay. So if you want to find interquartile range, you are not saying interfractile range. If you are defining interquartile range, then it will be 1 by 4 and 3 by 4. Okay, because you divide it into 4 parts. So 2, 2 and 2, 4 parts, right? So this is 1 by 4th quartile. This is 3 by 4 quartile. Median is 2 by 4. We don't call it quartile because it's a median. If you say where is 2 by 4, 2 by 4 is 1 by 2 and 1 by 2 is always a median. So quartiles are basically Q1 and Q3. So we call it Q1, quartile 1 and quartile 3. Q1 and Q3. Q2 matches with the median, so usually we don't write it. Okay. So if you divide data into 4 equal parts, the first one will give you first quartile and this one give you 3 by 4. So 1 by 4 fractile is basically Q1 and 3 by 4 fractile is basically Q3. Okay, so these are names for the quartiles. Similarly, these are deciles are usually denoted by D1, D2 up to Dn. So if you divide into 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this will be the middlemost will be D5, which is also the median. This is also the median as well. This can be written as D1. This can be written as D9 because you divide it into 10 parts. Now each part will have its name. From D1 to D9 are your deciles. And if you take the difference between D1 and D9, it will give you interdecile range. Okay, 9 by 10 fractile. This 9 is basically 9 by 10 fractile. D9 is 9 by 10 fractile because it is still a fraction. Okay, these all are fractiles, but they have their own names as well. Percentiles come from 100. If you divide into 100 parts, the middle one will be P50, right? The last one will be P99, and the first one will be P1, right? And so on. These are the percentiles. Okay. So this gives you a more accurate view. You see, the range is the whole thing. From 0 to 100 is the range. Median is the middle one. This is interquartile range. If you want to find other ranges, you can find that, like 1/3 and 2/3 gave you interfractile range and so on. Okay. Now important thing is variance and standard deviation. These are like mean is the best sometimes, most of the times I should say, and is the most widely used measure of center is mean, arithmetic mean. Similarly, the most widely used measure of dispersion is variance or standard deviation. Both are the same. you will see that variance and standard deviation come from each other. So this is the formula for the variance. What is this? Variance is basically if you have values x, right? You took the sum, you got summation x. And if you divide this summation x by n, let's say we talk about population first. So population is mu, right? Summation x by n gives you the mean, right? Mu is the mean. Now if you take the difference, the deviations from your mean, subtract every value, subtract mean from its every value. Let's say this is x1, the first entry is x1, so subtract mean from x1. The second is x2, subtract mean from x2, and so on. Okay, so subtract mean from each value. At the end, take the total. So this will be the sum of all x minus mu. This is always 0. The sum is always 0. If you take the sum, it will always be 0. But here you see we are taking the squares. So if you take the square, x minus mu whole square, now all will be positive. Because why this mean is always 0? Because you know some values are smaller than mu and some values are bigger than mu. So some will be negative values, some will be positive values. So they balance each other and they give you 0. But when you take square, all values become positive. Now this sum will not be 0. So this sum will be something. These are sum of squared deviations. We call them sum of squared deviation. First you have to subtract mu from each value, then you have to take the square of each value, and then you have to take the sum. Now if you divide this sum with total number of values, and we call it variance. Okay, these are called deviations. That how deviated you are from the mean, how far you are from the mean. Okay, so these are called the deviation. So sum of all deviations is always 0, but if you take the square deviation, they are minimum. So this is what this can be written as this as well. Both are the same thing. Okay, either you can make this table and get this sum, then divide this sum by n, you get the variance, or you can just take the square. This is easier formula. You can prove that they are equal. Just try it. Open the square, take the sum, and prove that these both formulas are the same. Take the square. What is the square? X square minus 2 mu x plus mu square, right? And now apply sum on it. If you apply sum on it, it will become summation x square minus 2 mu constant, so sum goes on x, and when summation applies on mu, it gives you n mu square constant. You know, when you apply sum on a constant, it gives you n times constant. The how many times you are adding. We are adding capital N number of times. Okay, so and now if you simplify, you will see that you get exactly this answer. Okay, so this is another formula which is easy. Why it is easy? Because here I don't have to subtract mu from every value. You are given x, just find x square, right? Just take the square of this x. Now what do you know? You need summation x, which gives you the mean, right? Which gives you the mean. And then you need summation x square, which you needed here. Okay, so these two things are needed. Replace mu summation x here, get the mu, replace summation x square here and mu here to get the variance. Remember, this summation x square is not equal to summation x whole square. Don't make this mistake. Summation x square is something else. Summation x square means you are taking the sum of all x values, then you are squaring. This means you are squaring every value and then taking the sum. Always remember, okay? So don't calculate this. This will be wrong. Summation x square is different. So what is the standard deviation? Standard deviation is just the square root of the variance. Whatever variance you got, if you take the square root of it, sigma is the notation for that, gives you the standard deviation. Okay, so sigma is the standard deviation. Take the square, sigma square gives you the variance. This is the notation for sigma. Okay, sigma. This is also sigma. This is also sigma, but it's a capital sigma. This is small sigma. Okay, so both are Latin letters. Capital sigma is used for the sum of the values, small sigma is used for the variance and standard deviation. So let's see this example. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values. What do you want? You want the square of it. So what I will do, I'm using the simple formula. I'm not taking the mean. And so if you take the square of 59, take the square of 47. I took the square of all these values. 3 square is 9, 3 square, 6 square is 36, and so on. Now we need total. So this is summation x and this is summation x square. So if you put summation x here, you get the mean, right? And if you put summation x square here, you will get the variance. Okay, so we put this value square x square here, and we already have the mean square, so we replace these value here and simplify. You got the variance. Got it? So this is your variance and standard deviation. So variance is of course in square because we took the square of everything. So this is 427 runs square, and 427 when you take square root, it is in the runs. Okay, because these were the runs made by different players in a T20 match. It's a cricket match. I don't know whether you are familiar with that or not. Oman also has cricket team. I think they will be in the next T20 championship as well. Okay, but very popular game in India, Pakistan, England, Australia, South Africa, right? Sri Lanka. They play cricket a lot. So once we have a group data, we have a problem, right? We always know that group data is a problem. But remember, when we calculated mean from raw data, it was summation x by n, right? And when we found the mean from frequency distribution, we multiplied each value by its frequency and then took the sum, right? And n was summation f as well. Then n becomes sum of the frequency, right? Same thing is happening here. Wherever you see x or x square, whatever, multiply it with the frequency. That becomes the formula for the group data. Wherever you see x, so if you are using this formula, don't multiply f inside. Multiply the whole thing by your f. Okay, here it's x square, so we are multiplying this whole x square by f. Okay, so this is your formula for the group data. So let's see an example for the group data, and standard deviation is all, of course, the square root of that. So we have exactly the same example which we did in the previous lecture when we were finding mean, median, and mode. We found mean, median, mode of this data, right? Balance in a bank account. So now what we need, this is frequency. We have classes frequency. So first thing we need x, right? So x is the midpoint. So we know how to find the midpoints. Between 0 and 50 we have 25, and now keep adding 50. Add 50, 50, 50, 50 everywhere, because 50 is my class interval. So if you keep adding 50, you will get these values. Now I got the square. Take the square of each number. You get 25 square is 625. 75 square is this. But because it's a frequency distribution, I cannot take the sum of just x square and x. Okay, this will be wrong. I need to multiply these with f. Okay, I need to multiply this with f and get fx square and then take this sum. This sum is needed. This is summation fx square. Okay, and this will be put here. This is summation fx square which we put here. X bar is already calculated. If you are calculating x bar here, then find f and x here as well. Then find another column. Get summation fx as well for x bar. Okay, so if you divide x bar, you will get x bar is equal to summation fx divided by summation f. But we have done it before. In the previous lecture, we calculated the mean. If you go back and see, we calculated x bar, which was 142 in this case. Okay, 142.25. But anyway, we can calculate it again. If you multiply f with x, and write it here and take the sum, okay, and whatever sum you got here, divide this by number of observation, which is 600, This is your n. If you divide by 600, you will get 142.25. So now we just replace the value of x bar. We replace the value of summation x square. Okay, x bar is here. Okay, and divided by n minus 1, we got this one. For population mean, we divide by n. For sample mean, we divide by n minus 1. That's the difference between sample and population variances. Okay, so population variance is sigma square, sample variance is written as s square. Okay, and only you just remember that when you are dealing with population variance, we divide by capital N, but when we using sample variance, we divide by n minus 1. Okay, so here it is n over n minus 1. So the formulas are little different for sample and population variances, and we got the answer, which is this one. So this is your variance 8003.28. If I take the square root of this, this will become the standard deviation. So this is the variance, this is the standard deviation. So this gives you the spread of the data, how far your values are from your middle value. Okay, so you can see here the difference between the population and variance. See, the formula here is little different. When you are dealing with the sample variance, you divide by n minus 1, and here in population variance you only had mu square, right? Summation x square by capital N minus mu square. But here you divide the first one by n minus 1, and second you multiply by n. You see, it's not just mean square. You multiply by n and divide by n minus 1. This is the extra term, second term. Okay, so this is the formula I used for a sample variance. So this was the example which I just did. Got it? So what is the sample score? Sample score is for each value. Every value has its score. Okay, if you take the difference, if you are given a value x, but now you have x bar mean, okay, and you have a variance as well, standard deviation. So if you take the difference of each value from its mean and divide by the standard deviation, okay, it gives you the standard score. So standard score basically gives you the where you stand from the average value, and it gives you the units in standard deviation. That is how many standard deviation you are away from the middle value, not actually where you stand. Let's say this is the middle value, x bar. Okay, so x bar is the middle value. So if you pick this observation, and if you just take the difference, this is x minus x bar, right? This is the difference that which we call the deviation, right? This is called the deviation, how deviated you are from the mean, but it gives you the actual value. But when you divide by the standard deviation, it tells you how many standard deviations you are away. How many standard deviations you are away. 1 standard deviation away, 2 standard deviations away, 3 standard deviations away, and so on. Because statisticians use S as its unit. When you divide something by a number, it changes the scale. Okay, let's say if you there are 12 inches in 1 foot, right? If I divide some number by 12, it gives me the scale in feet, not in inches now. 24 inches, if I divide it by 12, it gives me 2. But 2 is not in inches now, 2 is in feet now, right? So I changed my scale. How many feet you are away, how many inches you are away, right? So you can change your scale. Statisticians wants to see the difference in terms of standard deviations. They don't see the difference in terms of real units. Okay, that's why they divide by the standard deviation, that how many standard deviations you are away from the mean. So you can find the standard score. Let's say you want to find the standard score of 27. So you can subtract a mean from the 27 and divide by the standard deviation. This gives you the standard score. It means 27 is almost half standard deviation away from the mean. Almost half standard deviation away from the mean. Okay, your mean was 17, your standard deviation was 20. So half standard deviation is 10. So you see, 27 is 10 units away from 17 almost. Okay, so statisticians don't want to see how much difference you have from the middle value. Okay, it was 20, right? It was 10. The difference between this value and the middle value was almost 10, but they don't want what is 10. They don't know. They say it is half standard deviation away. Now they say, oh, okay, it is 10, because they know the standard deviation is 20. Got the point? So the last thing is coefficient of variation. What is the coefficient of variation? Coefficient of variation is when you see your standard deviation and compare it with your mean. Okay, if you divide your standard deviation with your mean, it gives you the coefficient of variation. Why we multiply by 100? Because usually we write it as a percentage. So in the last slide, 20 was your standard deviation, 17 was your mean. Okay, so if you multiply this by 100, it gives you 118. Okay, so this is called the coefficient of variation. It means if it is above 100, it means this is more spread than the mean, means your standard deviation is more than your mean. That's why it is more than 100. Okay, so spread is more. Data is very spread here. So if it is less than 100, then it gives you it tells you that the mean is less than the standard deviation. Standard deviation is less than the mean. So it means the spread is not that much. So if it is less than 100, your maybe has this type of shape. But if it is more than 100, like this 118, it means data is more spread like this. Okay, data is more spread. So values are far from your mean. Here the values are closer to your mean. You see, values are closer to your mean. Here values are far from your mean. Okay, so this is another measure which tells you more information about the data. All right, so this was all about measures of dispersion. Look at these examples carefully, and I do some examples. You can take examples from the book or from the assignment as well, and see you can calculate these things or not. Okay, so I will stop here. Hope you understand this. If you have any questions, of course you can communicate with me through the groups. Till then, bye from me. Stay home, stay safe. Allah Hafiz. Ma salam.